Hello, my name is Hamza. I'm going to talk about indoor localization with smartphones. Contents has introduction, need for localization, different localization systems, different localization techniques, indoor localization with embedded mobile phones, life map, energy efficient localization, challenges and conclusion. Introduction. In today's world, there are many smart devices which use network to communicate with each other. The need for interlocalization systems that can provide reliable access to location information in areas that are not serviced sufficiently by a global positioning system has continued to grow. Many localization systems currently being explored utilize a combination of complementary methods to enhance accuracy and reliability and decrease energy consumption of overall system. Need for localization. Global navigation satellite systems have transformed the way that people navigate, travel, automate, and gather information about the world around them. Indoor localization systems have the potential to similarly change how people function in locations where satellite based location systems are rendered ineffective. There is a need for these systems that can bridge this gap and create continuity in localization regardless of location. The ability to track people and equipment indoors has applications in many areas. Factory and warehouse automation through assist tracking and optimization analysis can serve to increase productivity by effectively scheduling resources and equipment. Hospitals can track patients, employees, and equipment to enhance navigation and allow for the automation of hospital information systems. Parking garages and underground parking structures could track their fill capacity, direct vehicles to open spots, locate vehicles, and ultimately enhance autonomous vehicle routing. Different localization systems. Modern localization systems use different techniques such as received signal strength indicator, time of arrival, time difference of arrival, and angle of arrival. Localization systems are classified into active and passive systems. Most of the indoor localization uses active system by tracking an electronic device and stating the results in a server using positioning algorithms. A person being tracked need not carry any device in the system. This system uses different methods such as device free passive, ultra wideband, physical contact, and differential air pressure. Different localization techniques. Many techniques have been proposed and they fall into two categories, namely fingerprinting based and model based. So I'm going to discuss about many techniques here. So first is peer-to-peer navigation technique. This system does not require pre-developed, pre-deployed location services and detailed floor plans, and it enables the fast to deploy navigation services by tracking user mobility. Peer to peer navigation consists of the trace generation part for the recorded information and the navigation part for the users using the recorded information. Smart next is smartphone based pedestrian dead reckoning technique. Smartphone based pedestrian dead reckoning technique is a Wi-Fi based positioning system which shows accuracy and extends coverage. This is the typical indoor localization method. SmartPedia tracks indoor users' location with reasonable location accuracy. The core process of smartphone has four steps, namely step event detection, heading direction estimation, step length estimation, and location estimation. The third one is activity sequence based indoor pedestrian localization. Global positioning system satellites has the limited access to the indoor people. For this purpose, activity sequence technique is used, which consists of several continuous activities during the walking process, like taking the elevator, walking stairs, turning at a corner, and taking the escalator. Activity sequence technique computes the pedestrian localization by matching the activity sequence to several points using hidden Markov model. A hidden Markov model is used to match the activity sequence to the node of the indoor and network. Fourth one is Wi-Fi fingerprinting based indoor positioning technique. This technique has much attraction because it does not require line of sight measurement of access points and achieves high applicability in complex indoor environment. The two major areas of Wi-Fi fingerprinting are efficient system development, deployment, and advanced localization techniques. Efficient system deployment includes reducing site survey, calibrating heterogeneous mobile devices, and energy efficiency. The fifth one is smartphones based crowdsourcing for indoor localization. Radio solutions such as sensors constructing the floor plan are previously recorded and loaded in the smartphones. In order to apply human motions to connect previously independent radio fingerprints, locating in fingerprint space LIFS is used. It has two phases, namely training phase and operating phase. Training phase is the phase where the fingerprint database is built, and the operating phase is the phase where it searches for database, and it is done when the query is enabled. The sixth one is accurate Wi-Fi based localization using peer assistance. Indoor localization with a very good accuracy is not possible to get because Wi-Fi signals have the distinct locations with the same signatures. A technique called peer assisted localization has been proposed to get the approximate estimation between the peer devices by building a prototype. The seventh technique is magnetic fingerprinting technique. Another technique called magnetic fingerprinting, wherein particle filter is used to improve the accuracy. For this, estimation errors have to be considered because it might take the system unreliable or there might be restrictions using the smartphone. The limitations of this technique are it uses magnetometer, so magnetometer readings may vary. It takes longer time to realize localization failure, step length estimation error, step miscounting, and change of heading offset. In order to overcome these limitations, few techniques are used. So, the techniques used are hybrid measurement model, localization quality estimation method, and motion estimation method. Next technique is multi-hypothesis particle filtering technique. To mitigate the to mitigate the drift errors and step detection limitations of pedestrian dead reckoning with handheld sensors in indoor and outdoor spaces, a map aided pedestrian dead reckoning algorithm has been used. The performance of these smartphones should be analyzed while using inertial and light sensors. Bayesian state estimation is used for multi-hypothesis particle filtering algorithm that is based on Monte Carlo process where the state comprises the calibration parameters that is needed to mitigate the remaining pedestrian dead reckoning errors. Filtering techniques aims at solving the state variables in real time. Next is indoor localization with embedded mobile devices. A proper framework with the embedded systems can be used to improve the sensors and track the efficiency. LearnLog framework that are more reliable for real-time implementation on smartphones are implemented, and it uses low overhead regression-based learning techniques. The basic components of LearnLog are step detection, inertial navigation, Wi-Fi fingerprinting, and enhancements with machine learning. In this framework, three learning algorithms such as k-nearest neighbor, linear regression, and non-linear regression with neural networks are used to assist with indoor localization. The advantage of regression is that it allows to predict a continuous dependent value with lower resource demands. Next topic is life map. Accuracy plays an important role in the indoor localization, and hence life map, a context provider, is used for local location services which operates on Wi-Fi, accelerometer, and GPS. To provide indoor location information that is combined with GPS and Wi-Fi positioning systems, LifeMap uses inertial sensors in the smartphone. LifeMap uses various sensors commonly found in the latest smartphones to extract context. Accelerometer hardware component is always turned on that would help life map when the battery consumption is high as the hardware component has low power consumption. A minimum set of sensors is activated when the component manager detects a change in the user's motion. In order to obtain energy efficiency, the component manager immediately deactivates the irrelevant sensors by obtaining the context from the activated sensors. Next topic is energy efficient localization. Efficiency of energy should also be tracked in order to avoid the consumption of more energy. Here, context assisting techniques can be used to get the good performance of the device and energy efficiency. Two schemes are used, namely energy efficient localization scheme and complementary context assisting energy efficient scheme. A typical energy efficient location based service schemes are used for indoor localization. A low power ZigBee interface can be used to substitute for the energy hungry in the Wi Fi interface. So, context aware schemes will be helpful to overcome this challenge. Complementary schemes used are indoor detection, battery interaction, and image based localization. Let us see the challenges. Despite the exciting existing developments in the area of indoor localization in recent years, a number of challenges still remain. Different use cases require disparate levels of accuracy and have varying requirements for deployed infrastructure and cost. Thus, a single localization solution may not be suitable for all scenarios. The challenges faced are evaluation, infrastructure and cost, setup requirements, power, sensor error, performance requirements, new sensor, and radios. Conclusion. In the present world, different techniques are used in order to do indoor localization using smartphones. Many algorithms and programs have been used to get the accurate results. Performance, accuracy, energy efficiency, monitoring sensors, reliability, navigation, location based services, everything are taken into consideration for each and every time the new techniques are used. However, the situation remains challenging in getting the highly accurate, reliable, and energy efficiency. If the project time has extended, I would have surveyed many other parameters that would affect the performance of these techniques and also how to overcome these challenges. Thank you.